Today we are getting balanced, we are getting centered, we are going through balanced equations for your A-level chemistry exam. So they are absolutely crucial to any kind of quantitative chemistry. They are really, really important. So let's make sure you are super confident with them. Let's start by going over a few of the key features. Basically, there needs to be an equal number of atoms on either side of the equation, and you add more atoms by adding reactants or products to either side. There's no method to do this apart from trial and error. You just have to find a way that works and keep trying. Practice makes perfect. Now, what's the point in going through all this effort? Well, they're very useful because balanced equations can be used to calculate masses of reactants and volumes of gases. And maybe I'll demonstrate this via some worked examples. Ooh, exciting. They're also really important for titrations. Now, titrations are an experimental technique for finding the concentration of solutions. They use balanced equations to calculate the concentration of an unknown substance from a volume of a known solution. The experimental technique involves the use of a burette and often an indicator. A small volume of solution is dropped from the burette into the reaction flask, and this is repeated until the indicator shows no further reaction happening. Okay, as promised, I'm going to run through an example to demonstrate the importance of balanced equations. Now, let's start by asking what mass of water will react with 7.99 grams of bromine. So the first thing we want to do in this scenario is to write an equation. Now, bromine reacts with water to produce bromium hydroxide and hydrogen bromide. So Br2, remember all of the halogens are diatomic. So they go around in pairs, they're a bit needy and like hugging their friends. So it's Br2. That reacts with water, which I hope you know is H2O. And that goes to bromium hydroxide. Now, halogens in group 7 and hydroxide have a 1 minus charge. So what's going to be the symbol for bromium hydroxide? It's BrOH. Br is going to be +1, OH is going to be minus. And then we have HBr, which is going to be H plus and Br minus. Okay, so that's our equation. Let's go through it. So the moles of bromine. Now, the Br2 is going to give us a relative molecular mass of 79.9. So we do 7.99 grams divided by 79.9 to get us 0.1 moles. If that calculation terrified you, make sure you check out the episode on the mole, which will make that all make sense. Now, we have our equation, and there's a 1-to-1 ratio because we know that Br2 plus H2O goes to BrH plus HBr. It's nice and balanced. So we know that we have 0.1 moles of water. Now, if we want to calculate the mass, we need to use the equation mass equals moles times mR. So we do 0.1 moles times 18, which is our molecular mass for water, and that gives us 1.8 grams. Okay, so I hope that made sense. If not, rewind it, listen to it again. It will all become clear. Maybe write it out too, that will help. So, another question. What volume of hydrogen gas will react with 2 liters of chlorine gas given that the reaction ratio is 1-to-1? Well, it's also going to be 2 liters. Great. That is a nice bit of stoichiometry. That's what we call ratios in chemistry to feel really smart. Now we're going to talk about ionic equations. Basically, these are used to describe reactions in solution. Ionic solids will dissolve in solution and will split into their constituent ions. So if we take NaCl, which is table salt, and we dissolve it, we'll get NaCl goes to Na plus Cl minus. Now, reacting in solution. Some of the ions dissolved in the solution will react, but some of the ions dissolved will not be involved in any reaction. And if they're not involved, they're called spectator ions. Now, ionic equations only include all of the reaction components. So spectator ions are left out. They're just happy to be there. They're just chilling, okay? But remember, in an ionic equation, the charge on each side should be equal, so they should be balanced. Now, do remember the name of those ions that aren't included in ionic equations. They are spectator ions. Okay, next we're going to talk about state symbols, which just says whether something's a solid, liquid, or a gas. Pretty straightforward. You probably are familiar with it from GCSE. An S means solid. L means a liquid, so pure liquid like water or like mercury. That's what you see in like a cute little thermometer. And then aqueous is dissolved in water. and it's used a little bit more often than L. You'll only really see L for water, to be honest. So something like sodium hydroxide, NaOH, that's going to be aqueous. So we've got solid, liquid, aqueous. There's one more. Can you think what it is? It's gas. So solid brackets S, liquid bracket L, aqueous brackets AQ, and gas brackets G. Those are the state symbols you need to know, and you need to be able to chuck them in to your balanced equations too. Right, so we did our nice bromine example. Should we go over something else? Are you guys feeling ready? Do you want some more? I know you do. I don't even know why I asked. So, what volume of steam will react with 24 dm cubed of ethene according to this balanced equation? So our equation is C2H4 plus H2O goes to C2H5OH. This is a special kind of reaction that will come up a little bit later in the chemistry course. So it's a nice little preview of what's to come. So I set out the equation. Do you remember the ratio between ethene and steam? So it's 1:1. I love a 1:1 ratio. It makes life that little bit easier. So simples, we know that we had 24 dm cubed of ethene, so we're going to need 24 dm cubed of steam because it's a 1:1 ratio. Isn't life fun? So that was a quick run through of balancing equations and why it's important, and it will feature a lot in future units. This was more just to kind of get you up to speed and get you feeling comfortable with it, and we'll be going into even more deeper examples in future episodes, so make sure you check those out. Thanks for listening.